One of the things you can do with an acid-base reaction in the lab is called a titration. A titration is a technique that you can find an unknown concentration, an unknown capital M, which remember is molarity. So for example, if we react hydrochloric acid with sodium hydroxide, an acid donates, a base accepts. This type of reaction, you can figure out the products just like you did when you did a double displacement or metathesis reaction. If we draw the arrow from the acid and it points towards the base, the H plus is going to be attracted to the OH minus end of sodium hydroxide. So that's going to make an H2O. The other part is we're going to pair up the positive sodium with the negative chloride, just like we did in the double displacement. So we'll have the salt created, NaCl. And remember, NaCl really doesn't stay together. It dissociates into Na plus and Cl minus, because ionic compounds, when they're aqueous, they also dissociate. So you could write it as NaCl, or you could dissociate it into Na plus and Cl minus. Either way is correct. What we're going to do with this reaction is add enough acid and enough base so we reach the equivalence point. That's when the moles of the acid equals the moles of the base. And you see this in the lab when you add an indicator to your solution. So for example, this Erlenmeyer flask might have the hydrochloric acid in there, and in the burette we put in the sodium hydroxide. The burette has a stopcock that you can open and close so you can add the sodium hydroxide in a controlled fashion. When the sodium hydroxide reacts with the hydrochloric acid, the indicator will turn a color, and this pink color tells you that you've reached the end point of the titration, which is the equivalence point of the titration. So this indicator turns from a colorless when it's in the acid to a pink solution when you add enough base to neutralize all of the acid. So here's an example with some numbers on there. You have 25 milliliters of hydrochloric acid. It has an unknown molarity. It takes 13.17 milliliters of a known concentration of sodium hydroxide in order to reach this equivalence point. We want to figure out what is the molarity of this hydrochloric acid. First step when you're trying to find molarity is write down the definition of molarity. Molarity is moles of solute, which in this case is hydrochloric acid, divided by liters of solution. And we have two different solutions. We have 25 milliliters of hydrochloric acid, and we have 13.17 milliliters of sodium hydroxide. This solution is for the hydrochloric acid. So it's 25 milliliters of the hydrochloric acid solution. So that's half of the unknown right there. If we can turn milliliters into liters, then we can get the denominator that we want. Conversion factor between milliliters to liters. 1 liter is the same thing as 1,000 milliliters. So whenever you have milliliters and you want liters, you end up moving the decimal over 3 places to the left. So this is 0.025 liters of the hydrochloric acid solution. The second part to this is figuring out the moles of hydrochloric acid. If we know that, then we'll have the numerator. We already know the denominator is 0.025 liters. Put both of those together, we'll have the molarity. And we'll do that on the next video.